Hello friends, welcome to EK lectures. In this lecture we are discussing the question number 5 and 6 from Karnataka Set 2021 physics question paper. So here is our question. Now the integral from minus infinity to plus infinity sin x divided by x square plus b square dx. Now to solve this integral we can follow the similar approach that we have done earlier. Consider f of z is equal to the function f of x, that's equal to we are just writing f of x in terms of z, so sin z divided by z square plus b square. Now according to the residue theorem, we are considering the complex function f of z equal to, instead of sin z we are writing e to the power iz divided by z square plus b square. Okay. Now finding the singularities. Singularities means where the function is not defined. So z square plus b square gives you 0, which means z is equal to plus or minus ib. Now since we are dealing with the integration over, so we are integrating from minus infinity to plus infinity, so this implies that we are interested in the behavior of the function in the real axis, so it belongs to real axis. This is because of the reason that it is from minus infinity to plus infinity. We are hardly bothering about y-axis. We do not, that means the imaginary axis. We are not focusing on the imaginary axis but on the real axis. Now the residue at z is equal to ib, this is what we need to find. Residue at z equal to ib, and we also need to find z equal to minus ib, the residues. Now so residue of the function f of z at z equal to ib is given by limit z tends to ib e to the power iz divided by 2z, that's equal to e to the power ib divided by 2 times ib. Now similarly the residue, this we can write it as e to the power minus b divided by 2ib. Now the residue at minus ib, so the residue of the function f of z at z equal to minus ib is equal to limit z tends to minus ib and e to the power iz divided by 2z, that's equal to e to the power minus I b times I once again divided by 2 times z is minus ib. So this gives us e to the power b divided by 2ib with a minus sign. And now the integral from minus infinity. So integral from minus infinity to plus infinity, e to the power iz divided by z square plus b square dz is equal to 2 pi I into sum over residues. So sum of the residues is what we need, so that's equal to 2 pi I into e to the power minus b divided by 2ib minus e to the power b divided by 2ib. So this gives us pi by b into e to the power minus b minus e to the power b. So this is the integration of the given function f of z. Coming to the second question, consider a 3 by 3 matrix A with the eigenvalues lambda 1 equal to 4, lambda 2 equal to minus 2 and lambda 3 equal to 1. Use Cayley-Hamilton theorem to find the inverse of the matrix A. Now what does the Cayley-Hamilton theorem says is A, the matrix minus lambda 1 times I into A minus lambda 2 times I times A minus lambda 3 times I equal to 0. Now this is the I is the identity matrix and this is the equation, characteristic equation. Now expanding this equation we will get let us substitute the value of lambda 1, lambda 2 and lambda 3, which gives us A minus lambda 1 is 4, so 4 times I, let us write it as 4i itself. So A minus 4i, A this is minus 2, so A plus 2i, and A minus lambda 3 times I equal to lambda 3 is 1, so I minus I equal to 0. Now let us expand this. What we get is A squared minus 2a, this is a times 2i is 2a. Now 4 minus 4i, so this is plus. Now minus 4i times a is minus 4a, and this is 8i minus 8i times a minus I. Now once again we will multiply with this equation with a minus I, which gives us a square it's a cube minus a square, now plus 2a squared minus 2a minus 4a squared plus 4a, then minus 8a plus 8i. Now this gives us a cube. Now this is square minus so this is a square minus, so 5, it becomes minus 3a squared. Now a cube is over, a square, and this is done. Now we need coefficient of a. This is minus 2 plus 4 minus 8, so that gives us
here becomes minus 6a plus 8i equal to 0. Now what we need to do is multiply by a inverse, and what we are going to get when we multiply by a inverse is a squared minus 3a minus 6i plus 8a inverse equal to 0. Now bring all the other terms except 8a inverse to the other side, so this becomes 8a inverse is equal to minus a squared my plus 3a plus 6i, and what is a inverse? A inverse is equal to 1 by 8 times minus a squared plus 3a plus 6i. Question number 5. Which of the following matrices is an element of SU of 2? Now SU of 2 represent the special unitary matrix. So let us write here special unitary matrix. Now what does a special unitary matrix says? Now SU of 2 is 2 by 2 matrix, 2 by 2 complex matrix. Complex matrices. Now the elements or the a matrix should contain complex numbers. Contain complex numbers, which means complex numbers, and the determinant has to be equal to 1 for this SU of 2 group, and one more property is that it is a unitary matrix. Now what is that the unitary matrix says? Unitary matrix says U star U equal to I, or that is equal to U star, or some U star is nothing but the conjugate transpose, complex conjugate transpose. This is also denoted by U dagger, complex conjugate transpose. Now the option A does not contain the complex numbers, so this is removed, and this can be our answer, and also this can be our answer. Now let us look into the option D. Now what does this says? Option D doesn't have any complex element, so this is also not our option. So option A and D is not our option. Now let us look into the matrix B. So that's 1 by 3, that is the matrix. Let us take the matrix as U equal to 1 by 3, 1 plus I minus 1, 1, and 1 minus I, and U dagger or U star will be equal to, so this is 1 by root 3. So 1 by root 3, the complex conjugate means the diagonal elements will become the its conjugate, that is 1 minus I, this will become 1 plus I, and the off diagonal elements, that is 1 and minus 1, will get reversed. So minus 1 here, this will become plus 1 and this will become minus 1. So this is the complex conjugate. Now u star u or uu star, so this becomes let us multiply this one, 1 plus I minus 1 minus I, sorry, this is 1, this is 1 minus I, times 1 minus I, this is 1 plus I, this is 1, this is minus 1. So 1 plus I and 1 minus I, that is equal to 1 square plus a plus b into a minus b, a square minus b square, which is equal to 2 here. So 2, then 1 minus 1 and minus 1 and minus 1, that is plus 1. So that is the first term. Now the second term will be 1 plus I here. So this is 1 plus I and minus 1 times 1 plus I. So this is minus of 1 plus I. Now this third term, this is 1 minus I and 1 times 1 minus I and 1 minus I times minus 1. So that is minus of 1 minus I. And the last term here, one times 1 minus I and 1 plus I, that is again plus 2. So this entire matrix will become, this is 3 0 0 3, and here you have 1 by root 3 into 1 by root 3, so this becomes 1 by 3, and here also you have to add 1 by 3 here. Now thus we have 1 by 3 times 3 0 0 3, so that's nothing but 1 0 0 1. This is nothing but the identity matrix I for 2 by 2 matrix. Now let us look into the another option. Here we have 2 plus I, 3I and minus 3I and 1 minus I. Now before going to find out the transpose, let us find out the determinant. Okay, now determinant should be equal to 1. So 2 plus I into 1 minus I minus minus 3I into 3I. So this is 2 plus this is 2 minus 2I plus I and minus I squared minus 3, so plus 9I squared. Now you see here, this is 2 minus 2I and plus I, minus 2I and plus I becomes minus I minus this is I square becomes plus 1 plus 9I square becomes minus 9. This becomes 2 plus 1 3, minus 9 is minus 6, so minus 6 minus I. Now this is a complex number and it is not equal to 1. So the determinant is not equal to 1, so you can readily remove this option. So how to go forward with this question is, first one is check the determinant, check if the determinant equal to 0 or not, and then there must be complex numbers. So you can also consider checking the first one. So the matrix should have complex number, then determinant, and if these two uh, 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 checklist have been done, then you can go for the third, that is u dagger u is should be equal to the identity matrix. So this is the method that you need to follow when you are checking whether the matrix is of SU of 2 group. Question number 6. Here, if in x1 x2 space the interval between two neighboring points is given by ds2 equal to 2 dx1 whole square plus 4 dx1 dx2 plus 6 dx2 squared, the element of the contravariant metric tensor Gij will be given by. Now here we have a space x1 x2 and we are asked to find out the contravariant metric tensor Gij through this distance ds2. Okay, now writing down the ds2, which is the separation between 2 points, as 2 dx1 squared plus 4 dx1 dx2 plus 6 dx2 squared. Now we need to find out the matrix which defines this distance or the separation. For that we are considering dx1 dx2, similarly dx1 dx2. So this gives us the matrix okay. So here we need to fill up this d. So dx1 dx1, so dx1 squared, so, and the coefficient is 2. Here 4 dx1 dx2, so dx1 dx2 is 4. Similarly here dx2 dx1 also will be there. This column is dx1 dx2 and this column is dx2 dx1, but both are same, dx1 and dx2. So we divide 4 dx1 dx2 by 2. 2 we will give here, 2 we will give here, so it becomes 2 dx1 dx2 and 2 dx2 dx1. So this is also 2 and this is 2, and the last one dx2 dx2 is the coefficient is 6, so dx2 square coefficient is 6. Now due to this reason, this is matrix is also called coefficient matrix. Now the next step, so first one is to find the coefficient matrix. Now second is to invert the coefficient matrix, invert the coefficient matrix. So let us name this matrix as C. So coefficient matrix C we are going to invert. So that is nothing but 1 by determinant of the coefficient matrix times the cofactor matrix. Cofactor matrix of C, or either cofactor, or it is also called adjugate matrix. So that's indicate matrix. Now that is given by the matrix cofactor matrix is so how is it being calculated? The ith row plus the jth column to the power, so this is minus 1 whole to the power I plus j times the determinant of that matrix. Now here when you consider the coefficient matrix C as 2 2 2 and we need to find out each element, so the cofactor matrix for this will be equal to the first row and first column get removed and 6 will come, so 6 will be remaining, so minus 1 whole to the power 2, I is 1, j is 1, so minus 1 to the power 2, that is e1, so that is 6, positive 6. And for these two quantities 2 and 2, the I plus j will be equal to odd, because this is 1 2, sorry, this is 2 1 and this is 1 2 column numbers, rows and column. So both sum is 3, so both of them will have so here we have the first one, we are looking at the second element here, that is first row second row. This will go and this will go and 2 will remain, sorry, this will be the second column and the so here for second element here we need to fill it with minus sign with the 2, so minus 2, and I'm looking at the third one, that is 2 1, so 2 1 means this and this will go, that is this column and this row, and 2 will remain again with a minus sign because it is odd. Now the last column, so 6 means this and this will go, 2 will remain, 2 with a positive sign because 2 comma 2 is 4. So this is the cofactor matrix. If you don't know, please understand how to find out the cofactor matrix for 2 by 2 matrix. Now the determinant of this coefficient matrix is what we want. Determinant is this product of this minus the product of this, so 12 minus 4 is the determinant, which is equal to 8, so determinant is 1 by 8, or determinant is 8, we have to divide by 8, then we get the first element, that this is the first element, the second element, third and fourth, so G11 is equal to 6 by 8, 6 by 8, which is equal to 3 by 4, and G12 as this one, minus 1 minus 2 by 8, which is nothing but minus 1 by 4, minus 1 by 4, and G21 is also equal to minus 1 by 4, and G22 is equal to 2 by 8, that is equal to 1 by 4. So these are the contravariant metric tensor Gij, and the option is option A. As practice work, we can find the answers to these questions. The matrix is given, we have to find whether it is an element of SU of 2. So the matrix is 1 by root 2 1 minus I 1. So this is one of the matrix. This is the question number 1, and for the question 2 we have the element ds2 is given by dx1 whole square plus 2 dx1 dx2 plus 3 dx2 squared. So this is one. So here also the question is to find the contravariant metric tensor, that is Gij. Please find the answer.